Auzubillahi minash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Welcome back in the chemistry lecture of 11th science. Today we are going to see about the quantum mechanical model of atom. Now this quantum mechanical model of atom was given by the Schrodinger's wave equation, one of the scientists, that is Schrodinger. Now try to understand, student, what is exactly quantum mechanical model of atom given by Schrodinger equation. Before that, which theory was elaborated before quantum mechanical theory? Just try to understand. Now why the Bohr theory was failed and what was the problem? What are the reasons for the failures of the Bohr's model of an atom? So Bohr's model of an atom treats an electron as a charged particle move in well-defined path of the circular orbit that we know very well around a nucleus. Its path can be defined if its position and momentum can be known exactly at the same time. But Heisenberg's uncertainty principle state that the momentum and position cannot be found simultaneously. But Bohr's model was insist to say that the position and momentum can find exactly simultaneously, it can be found out, but that was not true. This is not possible according to Heisenberg's principle. The model should account for dual nature of matter and should be consistent with Heisenberg's uncertainty principle. So that was a major problem of Heisenberg. Later on, quantum mechanical model of an atom came into existence. Before that, a classical mechanics based on the Newton's law of motion is applicable for the macroscopic object. Macroscopic object means a big object, not an electron, proton. These are the microscopic object. So macroscopic object due to the particle nature of matter. So classical mechanics theory came into existence, and while it fails in the case of microscopic particle, as I told you that classical mechanics theory was based on the macroscopic means large, and it was failed to explain microscopic particles. The classical mechanics ignore the concept of dual nature of the matter, especially for subatomic particle, that is proton, electron and neutron, and uncertainty principle, that is Heisenberg uncertainty principle. So that is why that classical mechanics theory was failed. Now what do you mean by quantum mechanics? Now try to understand what do you mean by quantum mechanics. A theoretical science that deals with the study of motions of microscopic particle which have both particle and wave nature is called quantum mechanics. A very simple definition has been given over here, that to study the motion of a particle which is having both characteristic, that is particle nature and wave nature, is said to be as a quantum mechanics. On this quantum mechanics we will understand about the Schrodinger wave equation. Now try to understand this Schrodinger wave equation. In the old syllabus it was given, but in the new syllabus textbook it has not been given. Just you have to understand what is the Schrodinger wave equation. Now the fundamental equation of the quantum mechanics was developed by Erwin Schrodinger, which led a Nobel Prize for him in the physics in the year 1933. This equation was given by the Schrodinger. In our textbook only this equation has been given. This is H psi. This is the Greek alphabet psi. H psi is equal to E psi. H psi is equal to E psi. And this H is there is a cap has been given, that is a vector quantity. H cap psi is equal to E psi. Now we will see what it is. Now this equation, which incorporate wave particle duality of a matter as proposed by de Broglie, is quite complex and knowledge to higher mathematics is needed to solve. So as this equation has been given, this d which is written in the oblique one, it is said to be as an daba, that is differentiation. But as of now you don't have to study this equation, so no need for the explanation. Just for your understanding, you can understand that this in the denominator, that is x square, y square and z square. That means the particle is the equation has been given with respect to 3 dimension, x axis, y axis and z axis. H is called as an, over here this equation you have to remember, H psi is equal to E psi is called as Hamiltonian, which is a total energy operator. E is called as an eigenfunction. Now try to understand, student, this H and psi, this Hamilton constant, it is a constant, and psi is a function. Say for example, a plus b is a equation which is given, and this H is an operator. Say for example, H is a square and function is a plus b, so a plus b whole square. So this operator H is acting on the function, so that is the meaning over here is the same, that H psi means square a plus b whole square. So ultimately we can find the value. E is also called as total energy of a system. The equation we don't have to study because it is given in the higher mathematics, so no need over here, and in our textbook also the equation has not been given. This equation is from the MSc part 1, so that students they are going to study. So now we are going ahead to understand a very simple part of the quantum mechanics has been given in our textbook in order to understand the structure of atom. Quantum mechanical model of the atom, now with the help of Schrodinger wave equation. Only Schrodinger wave equation you have to remember, that is H cap psi is equal to E psi. H psi is equal to E psi. Psi is wave function, hydrogen atom, and the Schrodinger equation. When Schrodinger equation is solved for the hydrogen atom, the solution gives the possible energy level that the electron can occupy and corresponding wave function of the electron associated with each energy level. These quantized energy states and corresponding wave function, which are characterized by a set of 3 quantum numbers, that is N, L, M, arises consequence in the solution of the Schrodinger equation. So with the help of that equation, what happened when it is solved for the hydrogen? So when the Schrodinger equation is solved for the hydrogen atom, the possible value of the energy that the electron may have along with the corresponding wave function, that is psi. To understand this Schrodinger equation, they have given a set of 3 quantum numbers. With the help of 3 quantum numbers, they are explaining the structure of atom. So now just we have to study the sets of quantum number, these 3 sets of quantum number. At the end of the chapter, in all we have to study the 4 sets of quantum number. That means 1 quantum number will again increase. The quantum mechanical result of hydrogen atom successfully predict all the aspects of hydrogen atom spectra, including some phenomena that could not be explained by the Bohr atomic model also. Schrodinger wave equation cannot be solved exactly for the multi-electron atom. For hydrogen and hydrogen-like atom species, energy of the orbital. Hydrogen-like species means what? He plus. If I say He plus, He is helium, atomic number 2, and if I say He plus, so it will be having 1 electron. So that is a hydrogen-like atom. Depends on N value, while the other it depends upon N and L. We will see this, what is N and L. It is a quantum number. Now features of quantum mechanical model is not important for you to go study because it is not in your syllabus. You can read it to understand, but we will go ahead and more focus on the quantum numbers. This equation we have to remember, h psi is equal to E psi. You can read this. We will study ahead in all these points in the quantum numbers one by one. Just you can read it and for your understanding. Next time we will study all four quantum numbers in detail.